everybody, I hope you're having a great day. Welcome back to the STEM Learning Series on Bouncy Vision. I hope you've been enjoying my videos so far. Thank you to all my subscribers and viewers for your love and support. If you already watched my previous video on microbit, you might have already got a good understanding on the BBC microbit. It's a good way to learn programming quickly and easily. I suggest you watch my previous microbit video if you haven't already. Today I'm very excited to share with you slightly more advanced projects along with my friends. Watch till the end to experience all the fun in coding and playing. Without further ado, let's get straight to the video. First, we have the very interesting temperature measurement project using the temperature sensor at the back of the microbit. Here is the temperature sensor, which is inside a processor. This can give you an approximation of the air temperature. My friend Azash will show you the code for it. Over to you, Azash.
Okay, so my microbit project is a temperature sensor. And the way we're going to do this is first, so as you can see, I've already made a variable called temperature/temp. And we're going to start off by putting a forever block in our space here. And then, as you can see, there is a temperature block at about the bottom of input. And now we're going to set temp to temperature. And then the reason temperature is a round block is because it outputs a value. And as you can see, when we implement a temperature block, you have a temperature simulator here on your virtual microbit. And now we are going to show what temperature it is, and the way we're going to do this, get the round temperature block, put it in here, boom, it's so easy. That's it. We now have a functioning microbit temperature sensor. So as you can see, here's -2. If I put it here, it's 4, 5, and then it slowly goes up. That's it. That is all you need to do.
Wow, well done, Azash. The temperature sensor is such a cool way to check the temperature. Now I put the temperature sensor inside cold water, and right now it says it's 1 degree Celsius, and it can tell what temperature it is in your room or outside or in like water by its temperature sensor that it has on the back of the microbit. Okay, now I put the microbit in hot water and it says that it's 61 degrees. So don't worry if you don't have a thermometer at home. You can always program the microbit and use it as a thermometer. Okay, let me clear this stuff quickly and come back to you. Stay tuned for the project Rock, Paper, Scissors, Lizard and Spock. I think all of you will be familiar with the 3-element rock, paper, scissors game. As well as the second project, we're going to add 2 more elements, Lizard and Spock. You probably haven't heard of this version, so let me show you how it works. Now I'm going to explain how the game works. So basically this is a fictional character called Spock, and this is a poisonous lizard. Those are the 2 things that are added from the rock, paper and scissors. So now I'm going to explain which one defeats the other. So, for example, scissors cuts paper, paper covers rock, rock crushes lizard, lizard poisons Spock, Spock smashes scissors. And then these are the deeper ones that make a star shape. So let's start here. Rock crushes scissors, then scissors decapitates lizard, lizard eats paper, paper destroys Spock, and finally Spock vaporizes rock. Now I'm going to show you how to code rock, paper, scissors, lizard, Spock. So first of all, you can go to input and drag down the second option which says on shake, just like this. Then go to variables, make a variable, and type in hand. I've already done this, I'm just going to click this cross. And you should come up with 3 options: hand, set hand to 0, and change hand by 1. Select set hand to 0 and place it right here. Then go to math and then go and select this pick random from 0 to 10 and place that right there. Then go to logic and select this if true then else statement and place it right here. Once you've done that, you'll basically come up with if blank then. So actually if true then. So instead of the true, you bring in if hand is equal to 0. So you get the equals from comparison right here, and you get the hand from variables here. Then show icon, which is right in basic and here. Show icon rock else if hand is equal to 1, so you just duplicate this and duplicate by right clicking or control and press your touchpad, and it says duplicate here, so duplicate that and change it to 1. And similar to paper, do it to scissors as well to say change it, duplicate it and change it to 2, and duplicate it, change to 3, and duplicate it and change it to 4. So you've all got this. Now you just need to change the show icon to paper, scissors, and it's slightly different for Lizard and Spock. Instead of going to show icon, go to basic and select show LEDs and make this pattern by clicking on these squares. And that's it for your code. So now I'm going to test out the code on the simulator. So when I press shake, it will randomly select one of the 5 options: rock, paper, scissors, lizard or Spock. So right now it's Spock. Change to scissors, rock, lizard and paper. So now I'm going to download it, which you can do right here. And then I'm going to, once I've downloaded it, I'm going to transfer it to my microbit. Now I've downloaded the game, I'm going to play the game. So how to play the game, you just say rock, paper, scissors, lizard, Spock, and you shake it. So I choose lizard. And that is scissors, and scissors decapitates lizard, so I lost. Okay, I'm going to say rock, paper, scissors, lizard, Spock, and this time I'm going to choose rock. And that's Spock, and Spock vaporizes rock, so I lost both the times. So I'll stop here and jump into the next project, which is Snap the Dot. This third project is another very interesting game, Snap the Dot. The game rules are very simple. You have to press button A when the dot reaches the middle of the microbit. Every time you hit button A exactly when it hits the middle, you get a point. Now my friend Karen is going to show you how to code the game Snap the Dot. Over to you, Karen.
Hello, today we're going to be doing a make code microbit project. It's going to be called Snap the Dot. As you can see here, I've named it and I've already made the code as well. So I'm just going to go through the code with you. Firstly, you should go to the variables block and you need to make a variable and you need to type in sprite like this. As you can see, I've already done it, and it will appear like this: sprite, set sprite to 0, change sprite by 1. You need to take this set sprite to 0 and put it inside the onStart block that you automatically see when you open up this sort of make code editor. Then you need to go to your game blocks. It should be under your advanced options. So right here, click this, click game, and you need the create sprite at x2, y2. You need to take that and drag it in. As you can see, it's like this right now. It would be like that. So you need to drag this into this, and that will be the code for the first part. Then in your forever block, you will need to go to game again, and you need to take sprite move by 1. You need to take this one, okay, and you need to drag it into there. Then then you need to go to basic, and there should be this one that says pause ms. So this will make sure, ms stands for milliseconds, and this will make sure it doesn't move too fast, it doesn't just go instantly. So when you try to snap the dot, it won't go that quickly. Alright, and then you need to go to game again, so under advanced, you need to get sprite if on edge bounce and just put it underneath that. Then your forever block is done. So basically now you have a project that sets a sprite and creates a sprite. The sprite will be an LED light. It can move by one and it can stop, and if it's on the edge it will come back. But you don't have any buttons or functions yet. That's where this part comes in. So first you'll need to go to input, so the purple blocks right here. You need to get on button A press, as you can see I've already done that. And then you need to go to logic and get an if then else statement. So it will look like this. It will look like this when you first start. So if I take this out, it will look like this when you first start. Okay? And then you're going to need a comparison block, which is also in logic, but it's under comparison. And you're going to need the one that says equals. Okay, so you're going to need to take that and keep it into, so right now it should say if true then. So you're going to need to keep your comparison block into here. After that, you're going to need to go to game, go to sprite X and put it in one of these circles, so this circle. As you can see, I've already done that. And then you need to change this would originally be 0. Then you need to change it to 2, so it will be yeah. So if it's on button A press, it's basically if the sprite X is equal to 2. So then you need to change score by 1, which is in the game box again, and it will be over somewhere over here. There you go. Change score by 1. You need to keep it underneath your if and then this part of your code. So this part. And in the else section you need to put game over, so it's again in game, and there you go, it's game over. You need to drag that inside, and that's basically your code. If I go to your simulator, the simulator that you automatically have built in, so you need to press button A as soon as it turns in the middle, as soon as the dot comes into the middle, you need to press the button A. See, I didn't do it, and then game is over. So you can make it harder if you want, or easier. You can change this, say 500, it will be slower, way slower. So if I restart the project, it just moves so slow, so you can do, there you go, 1 point, 2 point, or if you want, you can make it really fast, like say 50. Yeah, I lost. And that's basically everything.
Wow, this is very interesting, Karen. I particularly like the way you increase the speed of the dots moving from side to side to make the game more interesting. I can't wait to download the game and play it. Are you ready to watch me play Snap the Dot game? Let's start. So basically, the aim of the game is to press button A, which is on the left hand side, right when the dot reaches the middle right here. So for example, let me just show you. And when you get a point, it has like this sort of flashing thing, like that. And you can make it as fast as you want. Right now I've got it quite slow, around at 500 I think. You can increase it or decrease it to however you like. So right now I'm using 500. Okay, I'm going to purposely miss so you can see what the game over is like. So this is what the game over looks like. It says game over, and also it says the score I got. And I got 10. project is again a very exciting one. Once again, let me show you how the game works. The player has to move the basket left and right using the buttons A and B to catch the falling egg. For every right catch, you score a point. If you lose all 3 of your lives, the game is over and it will show your score. My friend James has put in a lot of effort to code the Catch the Egg game and sent it to me to share it with you all. I'll try to explain it the way I understand the coding.
So basically, let me just zoom in a little bit. This is what happens on start. So obviously you set the basket X to 2 and set basket Y to 4. So this is the X and Y coordinates to set the basket to. And then set life to 3, so you have 3 lives. Set score to 0. And plot basket X and basket Y to these coordinates up here. So then we've got the on button A pressed and on button B pressed. So this is moving the basket from left to right. So here you've got if basket X is greater than or equal to 1. So this line underneath the greater than symbol means greater than or equal to. So if the basket X is greater than or equal to 1, then unplot wherever it is, set basket X to -1, so it moves along to the right, and then plot it again so you can see it. And that's basically what happens on an on button B press. It's just the other way around, is +1, and it's if 3 is greater than or equal to basket X, then unplot basket X and basket Y, and then set it to +1 and then plot it again. And then this is the big part. This part is like so this part right here is the egg dropping down along the LEDs. So here says set egg X to pick random from 0 to 4. So that's picking a random spot at the top. So every time you catch it, it goes to a different spot. That's set egg Y to 0. And I forgot to say this. So if life is greater than 0, so this goes all the way down to all the way here. So all of this happens if life is greater than 0. And these are like embedded if statements down here. We'll get onto that later. So egg Y, so while 5 is greater than or equal to egg Y, plot egg X and egg Y, pause 500 milliseconds. MS stands for milliseconds. So this is how fast the egg drops down. Unplot egg X and egg Y and set egg Y to egg Y +1. And obviously egg Y is the vertical section. So this code is basically to show that the egg is going down. And over here you've got if basket X equals egg X and basket Y equals egg Y. So if you catch the egg, set score to score +1, so you've won a point. Pause for 700 milliseconds. Plot the basket again, and then again pick random from 0 to 4 for egg X. So basically same up here, plot it again so it's on loop. And then over here we've got if you miss the egg. So if egg Y is equal to 5, then set life to life -1. So you lose a life out of the 3 lives you already have. And over here it says if life is equal to 0, so if you lost all your 3 lives, then call game over. So this part looks, let me just drag it to the side. So this part looks pretty long, but it's just an animation that my friend has coded, James. So basically what it is, if you lose all your lives, it will show this animation all the way down here. It will show the animation, it will show game over, so it will show this string, and then it will show the score. So we've made a variable called score, so it will show what score you got. Pause for 1000 milliseconds, that's 1 second. Clear the screen, plot basket X and basket Y again, and then obviously if you want to play again, it will set score back to 0 and set life to 3, and then you can play it over and over again however many times you want to.
Really fantastic work, James. I really appreciate your brilliant coding skills to display the scores and lives remaining. I also love the cool animation at the end.
I couldn't resist trying out the catch the egg game, so here you go. Basically what I've done is I've made it way faster than it actually used to be, so it's more fun to play and it's more trickier. So at first I did it to 500 milliseconds, but now I've changed it to 200 milliseconds, so it's more interesting. And obviously there's only 3 lives, so I lost my 3 lives, so it says game over, and then it will show my score, which is 8. And you can keep on playing this, as after it says game over, it just automatically goes on to the next game, so you can just keep on playing it.
My huge thanks to Address, Karen and James for your amazing participation. I was really inspired by your great work. It was so much fun to work with you all for the past week. Learning together is so much fun. All the coding was done through the website microbit.org using the online block editor. You can find many other projects provided on the website. I enjoyed watching and doing all these projects with you all, and I hope you did too. Make sure to pay a visit to my previous STEM videos, which I will leave a link to in the description box down below. If you want to participate in my future STEM episodes, send an email to stem@vancevisions.co.uk to show your interest. You can also send your microbit projects too. The possibilities are endless. It's up to you what you want to do. Also visit the Vancy Visions website at https://www.vancyvisions.co.uk to know more details. All the information is listed on there. Please like and subscribe to Vancy Visions to show your support. And on that note, I'm signing off for today. I'll see you all in a midweek 60th special STEM episode. Have a great day, everyone. Take care. Bye.